We usually look at the world through the lens of headlines, what's breaking, what's trending, what's on fire. But today I want to flip the script a little bit. I want to look at the invisible nervous system that allows those headlines to even exist in the first place. We are diving into a comprehensive playbook, and we are going to deconstruct the architecture of modern enterprise IT. And before you tune out thinking this is just about, fixing printers, let me frame it differently. This is about the 11 layers of technology that basically stand between civilization and, well, total chaos.
And that's it, like no exaggeration at all. When people think IT, they visualize the person who comes to reset your password. But looking at this source material, that is, it's barely scratching the surface. We are looking at a stack that goes from the microchip in your phone all the way up to the massive cooling systems in a tier 4 data center that keep the global economy from, melting down. It is a massive interconnected ecosystem.
Exactly. And what really struck me going through this portfolio is how much we just completely take for granted. We open a laptop, we click a button, and suddenly there's a face-to-face video call flowing in from the other side of the planet. We swipe a badge, and a door magically opens, we buy a coffee, and money just moves. But underneath that simplicity is this Rube Goldberg machine of immense complexity. So our mission today is to take that machine apart piece by piece and really understand how it actually works. We're trying to move from tech support thinking to digital transformation thinking.
Yeah, and the timing for this discussion is, I think, perfect. Because the definition of work is fundamentally broken over the last few years, hasn't it? It's no longer a place you go to. It's just a thing you do. And that shift has put an immense amount of pressure on this entire infrastructure.
So let's start right there. That's a perfect jumping off point. Layer 1, digital workplace solutions. The source material draws a pretty hard line here. The digital workplace isn't just your cubicle anymore. It's an environment.
Right. It's the user's cockpit, in a way. And it's interesting because for a long time, the hardware you got from your company was actually worse than what you had at home.
Yeah.
You'd have a sleek iPhone in your pocket, and then this clunky 5-pound plastic brick on your desk.
Oh, absolutely. The beige box of despair.
Exactly. That gap is pretty much closed now.
Yeah.
The source highlights the whole hardware ecosystem, HP, Dell, Lenovo. But the real nuance is in the segmentation. You don't just buy computers anymore.
No, you buy specifically for the role. I noticed the distinction they made between the standard commercial laptops and then the workstations. We aren't just talking about running spreadsheets here, are we?
No, not at all. These are for the creators, the power users. We're talking about the engineers running complex CAD simulations for, say, skyscrapers, or the data scientists who are training AI models right there on their local machine, or video editors rendering 8K footage. These machines are absolute beasts. They are, for all intents and purposes, portable servers.
Okay, but then you have the complete opposite end of that spectrum, which I found fascinating.
Yeah.
The thin client. Yes.
I have to pause you there because thin client feels like a blast from the past. I remember those from the 90s. They were basically dumb terminals. I honestly thought we moved past that. Why would a modern enterprise want to give their employees a box that has, well, no brain?
It does sound counterintuitive, doesn't it? In an era where everything is smart, why would you want to go dumb?
Yeah.
But look at it from a security and a compliance perspective. If you are a bank, or maybe a high-security government facility, or even a factory floor, do you really want sensitive data sitting on a hard drive under someone's desk?
Well, no. If someone breaks in and just steals the box, they have all the data.
Precisely. With a thin client, the box is just a window. It has a keyboard, a mouse, and a screen. But the brain, the operating system, the files, all the processing is happening on a secure server, maybe miles away in a locked data center. So if you steal a thin client, you've just stolen a piece of plastic. There is zero data on it.
So it's the ultimate burn phone of computing. In a way, yes. And it's also about maintenance. Think about it. If a standard laptop dies, IT has to spend hours setting up a new one, transferring all the files, reinstalling the applications. If a thin client dies, you throw it in the recycling bin, you plug in a new one, the user logs in, and their desktop is exactly where they left it. The whole process takes, what, 30 seconds?
That's a huge difference in productivity. Okay, so that brings us to the software layer that kind of binds all this hardware together. We see the usual suspects, Windows 10 and 11, Mac OS for the creative types, Linux for the developers. But the real meat of this section, I think, is the management layer. The source talks about tools like Microsoft Intune, SCCM, and MDM, which is mobile device management.
Yeah, and this is where the scale of the enterprise creates the problem. Managing 10 laptops is easy. You can walk around and install updates yourself if you have to. But managing 20,000 laptops spread across 3 continents, that is a logistical nightmare.
I've always wondered about that remote wipe capability you hear about. It feels like something out of a movie. The spy leaves the laptop in the taxi and headquarters presses a big red button. Is it really that dramatic?
It is absolutely that dramatic, and it saves companies every single day. But it's actually gotten more sophisticated than just wiping everything. Now it's about containerization. Let's say you want to use your personal phone for work email. Do you really want your company to have the power to wipe your family photos?
Absolutely not. That's a huge privacy line.
Right. So modern MDM tools create a secure container, like an encrypted bubble on your personal phone. All the corporate data, the emails, the files, they live inside that bubble. If you quit your job or you lose the phone, IT just nukes the bubble. Your cat photos stay perfectly safe. Their trade secrets disappear into the ether. It's the perfect balance between user privacy and corporate security.
That's really clever. And speaking of security at the endpoint, we have to talk about DLP, data loss prevention. The source mentions this alongside brands like CrowdStrike, Sophos, and Trellix. This is the stuff that stops you from, say, plugging in a random USB drive you found, right?
It is, but it's gotten so much smarter than that. It's not just about blocking USB ports anymore. Modern DLP watches the data itself. It's context aware. So if you try to take a file that's labeled confidential and attach it to a draft in your personal Gmail, the system steps in. It basically says, I'm sorry, Dave, I can't let you do that. It prevents accidental or, intentional stupidity.
So we've basically built a fortress around the laptop, but a fortress is pretty useless if it's an island. These people need to be able to talk to each other. And this brings us to the second layer, audiovisual and collaboration. And I feel like this is the area where expectations versus reality have clashed the hardest since 2020.
Oh, absolutely. The meeting room as we knew it is dead. Long live the collaboration space. The source material makes this shift very clear. We used to design rooms for the people who were physically inside the room. Now we have to design rooms primarily for the people who aren't there.
And that's this concept of meeting equity, isn't it?
Precisely. We've all been that remote person on a call where the room is just a long bowling alley style table. The people at the far end look like tiny little ants and you can't hear what they're whispering to each other. What do? You check out, you disengage, you become a second-class participant in the meeting.
So how does the hardware fix what is at its core a human problem? The source lists a bunch of innovative devices from companies like DTN, Logitech, Poly, and Cisco.
It fixes it with AI. That's the short answer. We are seeing cameras now, PTZ cameras, which stands for pan, tilt, zoom, that don't just stare blankly at the room. They actually watch the conversation. They follow the speaker. So if I start speaking, the camera intelligently zooms in on me and frames my head and shoulders perfectly. If you interrupt me, it might split the screen and show both of us, like a real broadcast.
So it's essentially a little TV director living inside the soundbar.
That's a great way to put it. And the audio side is just as critical, maybe even more so. The source mentions a technology called acoustic fencing. Imagine an invisible sound wall drawn around the meeting table. If someone is standing outside that wall in the hallway talking loudly about their weekend, the microphones just ignore them. Or someone inside the fence crinkles a bag of chips, the nemesis of all conference calls. The AI identifies that frequency and filters it out in real time.
Okay, that's incredible. The source also touches on room automation, the whole concept of the one-touch join.
The Holy Grail.
It really is, though, because we've all spent that first 10 minutes of a meeting fumbling with HDMI cables, asking, can you hear me? Trying to find the right input on the remote.
And all that friction just kills productivity. It kills the momentum of the meeting before it even starts. The whole goal of automation using room schedulers and touch panels is to make the technology completely invisible. You walk into the room, you press one big green button that says join, and the room just wakes up. The lights dim to the right level, the screen drops down, the call connects automatically. It respects your time.
The outline also breaks down different use cases, like the HOD cabin versus a full boardroom.
Right, because one size doesn't fit all. The head of department's office, the HOD cabin, needs to be clean. Minimalist. They often go for an all-in-one touchscreen device, like a D10, D7X. It's the camera, mics, speakers, and whiteboard all in one unit, no clutter. But the boardroom is different. That's a high-stakes environment. There you'll see dual displays, one for the content, one for the people. You'll have advanced ceiling microphones to pick up everyone clearly. The goal is to make the remote board members feel like they are physically in the room.
And then you have the auditorium.
That's a whole different beast. We're talking about spaces for 100 to 500 people. That requires full AV automation, huge LED video walls, multiple wireless microphones, and complex sound systems to avoid feedback. It's basically a small-scale concert venue setup.
Okay, so we're moving from the boardroom down to the basement, or, the cloud. Let's talk about the engine that powers all of this. Section 3, data center
The
solutions.
heavy iron, the real engine room.
When I read through the specs here, servers from HPE and Dell, storage from NetApp, I'm reminded that the cloud is really just someone else's computer. But for many big enterprises, they still want to own the computer.
They absolutely do. And if you've ever walked into a proper Tier 4 data center, you know it's a visceral experience. It's not some quiet library of servers. It is deafening. It's the sound of thousands of fans screaming at high RPMs to keep all that silicon from literally melting. And it's cold. It feels like a meat locker that's been designed for doing math.
Let's unpack the storage aspect because the source makes a clear distinction between SAN and NAS. To the average person, a hard drive is a hard drive. What's the real difference here?
Think of it like a warehouse versus a library. That's the best analogy. NAS, that's network attached storage, is the library. It deals with files. You go to the right shelf, you pull out a specific book, a Word doc, a PDF, a video file, you read it, and you put it back. It's great for humans sharing work across an office network.
Okay, so that's the library. And SAN?
SAN Storage Area Network is the warehouse. It deals in blocks of raw data. It doesn't know or care about files. It cares about raw speed and volume. It connects directly to the servers that are running heavy-duty databases like SAP or Oracle. When your credit card transaction needs to be verified in, 0.02 seconds, that's happening on a SAN. It's much more expensive, much more complex, and absolutely critical for high-performance applications.
The source also highlights virtualization VMware, Hyper-V. This feels like standard practice now, but can you just explain the economics of it? Why was it such a big deal?
Well, before virtualization, the rule was one app, one server. It was incredibly inefficient. If you had an email server, a database server, and a file server, you had to buy 3 separate physical boxes. But computers are incredibly fast, and most of the time those servers were sitting there at like 5% CPU usage. They were just idling.
Wasting power, taking up physical space in the rack.
Exactly. Virtualization is like building an apartment complex instead of a bunch of separate houses. Instead of building 3 separate houses on 3 separate lots, you build one giant skyscraper, that's the physical server, and you put 3 apartments or virtual servers inside it. They all share the plumbing, they share the foundation, but they act like completely separate, isolated units. You can now run 50, even 100 virtual servers on a single physical box. The cost savings are just astronomical.
But that creates a huge concentration of risk, doesn't it? If the skyscraper falls down, everyone loses their home at once.
Which is precisely why the physical infrastructure layer that's mentioned in the source is literally life or death for a data center. We're talking about UPS, uninterruptible power supply, and PAC, which is precision air conditioning.
I like that term precision. It's not just sticking a window unit in there.
No, absolutely not. If the temperature in a data hall swings by just 5 degrees, or if the humidity drops and creates static electricity, you can fry $1 million worth of equipment in seconds. These PAC units maintain the environment with, well, surgical precision. And the UPS, that's the bridge. If the city grid fails, the UPS batteries take the entire load instantly, 0 interruption, for just long enough for the massive diesel generators outside to roar to life. It's all about achieving 5 nines of availability. That's 99.999% uptime.
But not everyone wants to build their own private bunker, right? That leads us perfectly into Section 4, Cloud Solutions. The source covers the trinity, public, private, and hybrid.
This is the utility model of computing. Instead of building your own power plant, you just pay the electric bill. Public cloud, AWS, Azure, Google, is essentially renting that massive scale from them. Private cloud is when you build that cloud-like on-demand infrastructure, but you keep it in your own data center for security or compliance reasons.
And hybrid is the best of both worlds, I'm guessing?
It is. You keep your most sensitive data, your crown jewels, on your private cloud, but you use the public cloud for less critical things, or for bursting capacity when you have a sudden spike in traffic, like on Black Friday.
The really interesting piece for me here was disaster recovery, or DR. The source pitches the cloud as the ultimate backup plan.
It's what's called the pilot light strategy, and it's a game changer. In the old days, if you wanted a backup data center, you had to build a whole second building, fill it with millions of dollars of identical servers, and then let it sit there empty, just waiting for a flood or a fire at your headquarters. It was a massive, massive waste of money.
Just burning cash for insurance, basically.
Exactly. With the cloud, you build a sleeping version of your infrastructure. It costs just pennies an hour to keep the configuration files, the pilot light burning. If disaster strikes your main site, you flip a switch, the cloud spins up thousands of servers instantly from that template, and you're back online in minutes or hours instead of days or months. You only pay for the heavy compute when you're actually in a crisis.
That's a very compelling argument for any CFO. Okay, so we now have the endpoints, we have the collaboration tools, we have the servers, and we have the cloud. But they all need to connect. Section 5, networking solutions.
The nervous system itself. Switches, routers, firewalls. Brands like Cisco, Aruba, Juniper, Fortinet. Switches handle the internal traffic inside your office, routers connect different networks together into the internet, and firewalls are the security gates.
I want to focus on SD-WAN because the source calls it a game changer for businesses with many branches, like retail chains or banks. I've heard it described as smarter plumbing, but that feels a bit reductive. What is this software actually doing?
Think of it like Waze or Google Maps for your data packets. It's about intelligent routing. The old way of networking for branch offices was called MPLS. It was like having a dedicated private train track between each location. It was very secure and reliable, but if there was a problem with the track, you were stuck. And it was incredibly expensive to build and maintain.
So SD-WAN is the public highway system.
SD-WAN is the intelligent traffic control above the road. It looks at all the available paths, broadband internet, 5G, even that old MPLS line. And it says, okay, this video call packet is super urgent, but there's a traffic jam on the main broadband line. So I'm going to route this specific packet over the 5G connection instead. And this email packet, which is less urgent, I'll send over the slower DSL line because it doesn't matter if it takes an extra second. It dynamically routes traffic application by application to ensure the best performance, using cheaper internet connections instead of those expensive dedicated lines.
So it's real-time traffic management for data.
That's exactly. It saves companies massive amounts of money while actually improving the user experience. It's a huge win-win.
Let's talk about wireless for a second. The source emphasizes enterprise-grade Wi-Fi. I think a lot of people struggle with this. Why can't I just go buy the same router I have at home? It covers my whole house just fine.
Well, it covers your house with maybe 3 people and a dog. Now imagine putting 500 people in an auditorium for a conference, all trying to upload photos to Instagram or download a presentation at the exact same moment. Your home gear would just collapse under the load. It's all about density. Enterprise access points from brands like Aruba are designed to talk to each other. They constantly balance the load. If one AP gets overwhelmed with users, it intelligently pushes some of them to a neighboring AP with more capacity. And then there's roaming. If you're on a Wi-Fi call and you walk from the lobby to the 40th floor, your call shouldn't drop. The network has to hand you off seamlessly. Home gear just doesn't have.
Okay, so we have the network. It's smart. It's fast. Now we have to defend it. Section 6, the immune system cybersecurity.
And the main headline here is that the perimeter has completely collapsed.
What do you mean by that, the perimeter?
So 10 years ago, security was like a castle. You had a big wall and a moat. That was your firewall. If you're inside the castle, you were trusted. If you were outside, you were a threat. Simple. But now, with cloud applications and remote work, everyone is outside the castle. The data is everywhere. Your users are everywhere. So that old firewall model just isn't enough anymore.
And this is where the concept of identity comes in, right? The source mentions IAM and MFA.
Identity is the new perimeter. That's the mantra. It doesn't matter where you are physically located. What matters is who you are and can you prove it. That's why multi-factor authentication, or MFA, is absolutely non-negotiable today. But the source also mentions this really important concept of zero trust.
The never trust, always verify idea.
Right. Just because you have the correct password and just because you're on a company-issued laptop, the system still needs to check other signals. It might say, wait a minute, you're logging in from North Korea at 3 a.m. You usually work in London at 9 a.m. I don't trust this.
Right.
That's called conditional access. It might let you in, but it's going to ask for another form of verification or maybe restrict what you can access.
The source also dives into the monitoring side of things, CM and SOC. That's security information and event management.
This is all about looking for the needle in a stack of needles. It's a visibility problem. Your entire network servers, firewalls, laptops, generates millions and millions of log entries every single day. Every login, every file opened, every website visited, it's just noise. A SIEM platform aggregates all that noise from thousands of devices into one place and uses AI to look for suspicious patterns. And the SOC, the Security Operations Center, that's the human layer on top of the SIEM. Yes. The eyes on the glass, as they say. Because the software can flag an anomaly, but you still need a human analyst to look at it and say, okay, is this a hacker executing a malicious script, or is this just Bob from accounting who forgot his password 5 times in a row? The SOC is the 247 war room where those decisions are made.
Okay, moving from the digital war room to the physical one, Section 7, surveillance and physical security.
Yeah, this has merged completely with IT now. It used to be the facilities guy with a big ring of keys and a VCR tape that he'd change every day. Now it's a full-blown IoT or Internet of Things ecosystem.
The cameras themselves are just so much smarter. We've moved from just passively recording to actively analyzing.
Exactly. It's the shift from being reactive to proactive. Old CCTV was for watching the tape after the robbery to see who did it. New AI-powered surveillance is about stopping the robbery from happening in the first place. It uses things like geofencing and intrusion detection. If a person crosses a virtual line drawn on the screen at 2 a.m. in a restricted area, the system doesn't just record it. It can trigger an alarm, automatically lock the doors in that area, and send a live video feed directly to a guard's phone.
The source also mentions things like heat mapping and people counting. That's not just security, is it?
No, that's business intelligence. And it's huge for retail and for safety. For retail store, knowing which aisle gets the most foot traffic can help you optimize your product placement. For a large venue, knowing that a crowd is forming in a specific hallway before it becomes a dangerous stampede risk is critical. The camera is no longer just a security device, it's a business intelligence sensor.
Okay, we've built an absolute monster here. We have data centers, cloud services, networks, security, surveillance. It sounds incredibly expensive, and it sounds almost impossible for one company to manage all by itself.
And that leads us to Section 8, Managed Services.
This is the answer to the fundamental business question. How do we sleep at night?
The source lists offerings like IT Help Desk, Infrastructure Monitoring, and AMC, which is annual maintenance contracts. It's essentially outsourcing the stress.
It's also solving the CapEx versus OpEx problem, but for talent. It is incredibly hard and incredibly expensive to hire and retain a top-tier database expert and a top-tier network engineer and a top-tier security analyst. These people are expensive and they are very hard to find. Managed services lets you effectively rent that expertise on a subscription basis.
And it handles the boring but essential stuff like patch management, the vegetables of the IT diet. Nobody wants to eat them, but if you don't, you get really sick. Keeping 5,000 servers updated with the latest security patches is tedious, soul-crushing work. But if you miss just one critical patch, that's how you get hacked. So outsourcing that to a dedicated team or, increasingly, an automated system is a complete no-brainer.
I want to talk about SLAs for a second service level agreements. Because this is where the rubber really meets the road, isn't it?
It's the guarantee. It's the contract. We promise 99.9% uptime for this critical application.
And if the provider fails to meet that SLA, they pay financial penalties. It aligns the incentives perfectly. They don't get paid to fix things when they break. They get paid to keep things from breaking in the first place.
So if managed services is all about keeping the lights on, Section 9 is about what you actually do under those lights. AI, analytics, and automation.
This is the fun part. This is moving from just maintenance to intelligence.
I love this concept of RPA, robotic process automation. It sounds very sci-fi, but it's actually incredibly practical. It's what they call swivel chair automation. Think about a process where an employee has to open an email, copy an invoice number from a PDF, swivel their chair, open up the SAP application, paste the number into a field, and hit enter. That is a colossal waste of human potential. RPA is just a software bot that you train to do that exact task 10,000 times a second with 0 errors.
And it frees up the human to do the actual thinking work, the exception handling.
Exactly. And then you have business intelligence, or BI dashboards.
The death of the monthly PDF report.
Yes. A CEO doesn't want to wait until the 5th of next month to find out how sales were last month. That's ancient history. They want to see the dial moving in real time, right now. BI platforms pull data from the factory floor, from the sales CRM, from the financial system, and put it all onto one interactive screen. It turns raw data into actionable decisions.
Section 10 takes all these generic tools and applies them to specific worlds, which I think is a crucial piece of context. Let's take manufacturing, for example.
That's all about the convergence of IT and OT operational technology. That robot arm on the assembly line used to be a dumb, isolated machine. Now it's connected to the network. It's covered in sensors that are constantly sending data to a server. It can tell the system, hey, my vibration levels are slightly off. Based on my historical data, I'm probably going to fail in the next 48 hours. That's predictive maintenance. It saves millions of dollars in unplanned downtime.
What about healthcare?
In healthcare, latency is life. A doctor in the emergency room pulling up a massive 3D MRI scan cannot wait for a buffering wheel to spin. The network has to be instantaneous and flawless. And the security. Patient data is actually more valuable on the black market than credit card numbers.
Why is that?
Because you can cancel a credit card in 5 minutes. You can't cancel your medical history. It's used for sophisticated insurance fraud, identity theft, even blackmail. So the security wrap around healthcare IT has to be incredibly tight.
And banking, or BFSI as the source calls it.
That's all about regulation. They are terrified of data loss and downtime, not just for business reasons, but because the government mandates certain levels of resilience. For them, disaster recovery isn't just a nice to have, it's a legal requirement.
Okay, finally, Section 11. We've looked at all the parts, which positions itself as a system integrator. Why does that role even exist? Why not just buy the Dell laptop from Dell and the Microsoft license from Microsoft?
It's to avoid what's known in the industry as the vendor tennis problem.
Vendor tennis.
Imagine your critical video conferencing system goes down right before a board meeting. You call the network guy, he runs some tests and says the network is fine, it must be the software. So you call Microsoft. They say Teams is up and running globally, it must be the laptop. You call Dell, they say the hardware is perfectly fine, it must be the firewall. Everyone just hits the ball back over the net to someone else, and your business is still down.
That sounds absolutely infuriating.
It's the nightmare of every CIO. A system integrator acts as the one throat to choke. They are the general contractor. They design the whole solution, they build it, they integrate all the pieces. If it breaks, it's their problem to solve. They own the complexity. They are the ones who ensure that the Cisco camera talks to the Poly software, which talks to the Aruba network, which talks to the Azure cloud. They own the entire stack so the client doesn't have to.
So we've really journeyed from the device in your hand to the depths of the data center, up through the cloud, across the global network, and behind the shield of cybersecurity. It really is a nervous system, isn't it?
It is. It senses, it thinks, it reacts, and it protects.
And as we look to the future where the AI is analyzing the surveillance data, which is talking to the cloud, which is automating the repairs on the network, I have to ask, are we moving toward the self-healing enterprise, a system that can basically run itself?
I think we are, absolutely. Imagine a world where a server starts to get too hot. Before a human even knows there's a problem, the AI automatically migrates the workloads from that server to the cloud. Then it safely shuts down the failing hardware, logs a ticket with the manufacturer for a replacement part, and reroutes all the network traffic around the issue. The system maintains itself autonomously. We are very, very close to that reality.
That is both incredibly exciting and, I have to admit, a little bit terrifying. But I guess that's the nature of progress.
Indeed.
So for everyone listening, next time you walk into your office, just look around. Look at the blinking light on the Wi-Fi access point, the badge reader on the door, the laptop on your desk. Don't just see them as objects. See the layers. See the invisible architecture that keeps the modern world running. It's a true marvel of engineering, and it's happening all around you all the time.
Invisible until it breaks, but absolutely beautiful when it works.
Thanks for diving deep with us into the architecture of modern IT. It's been a fascinating ride. Catch you on the next one.